In lesson two, we are going to be talking about ocean movements and how that water goes through and from one place to another. First, let's talk about waves. Waves actually have different parts. The top part of a wave is called the crest, and the lowest part of a wave is called the trough. The distance between two crests, so the top of one wave to the top of the next wave, is the wavelength. And when you're discussing the height of the wave, you go from the trough, the lowest point, to the like crest point, and that is your height. And then the energy of the wave at the surface, there's more energy in that wave, and it gets less and less until it dies out to the wave base where there's not much energy left. So I think I should have started to tell you what is a wave, and it's essentially some energy that's being carried through. It can be carried through water, it can be carried through air, it can be carried through solids. But in this case, we're going to be looking at carrying that through water, and it's that energy that's carried through basically by rhythmic movements, by the energy being passed from one molecule to the next, the next, to the next. So the water doesn't exactly um, move, it just vibrates and pushes the energy to the next water molecule. So a lot of times you don't even have all of this water ending up, for instance, on land. It's just a push of energy through the system. So, and that's more of a physics principle, but just for sake of interest, because that's interesting. So, as waves move towards land and it gets shallower and shallower, that energy gets transferred to the upper water molecules that are not hitting the land. And so, eventually, a crest forms, like a breaker forms on the top of the wave, and the wave will curl forward and break on the shore. So, depending on what the ground looks like underneath, you can have a very, if it's very sandy and gradual, you'll have waves that slowly gave away their energy and they're not breaking very large. You can also have beaches that are shaped at more of an angle where all that energy comes and hits at once, and it will break on the shore very, very violently. So it just depends. So there's some beaches that are better, for example, in Southern California for learning to surf because they have like slow, steady waves, and some that it breaks really sharply that you have to decide if you'll maybe get bigger waves, but depending on how it breaks on the shore, maybe you want that, maybe you don't. So tides are actually the rising and falling of the ocean. And I like this picture in some ways. So if the moon does have gravity, and that gravity does pull on not just you, but also all the water on the planet. And so when the moon is over here on this side of the earth, this water will get pulled. It'll get pulled from both sides. To make a high center. And this is again exaggerated, as most of these pictures are to show you, but it's just interesting. The sun also has a, and then I'm sorry, I should go back. And then you have a lower tide when the moon is not, um, like when the moon is more perpendicular to wherever you are, you're going to have a lower tide. You can also get an extra high tide if the sun and the moon are in alignment. You can get a larger tide. Sometimes this is called like a king's tide, where you can get a very high tide there. And you can have some lower tides when the moon is perpendicular with the sun. So those are different types of tides that you can have. So currents is another thing that we need to talk about in this section. So, currents affect the top of the ocean water. So, specifically, it affects the top 100 to 200 meters of water. That's quite a bit. of water, and it can be affected by there's several things that can drive these currents and make them move. Let me go to a picture of some currents. So there can be different things that affect that. Most of it is winds at the top surface. You can have like the westerlies or the easterlies. You can have the trade winds affect it. You can have landforms that the currents run into. So then they you know hit into the land and go a different direction. You can even have large effects like the Coriolis effect, which affects very large objects. Here are some major ocean gyres. That's where different currents have basically a current has gotten deflected, and so it's pushed it in a different way, and it's made kind of a closed circle current system that develops um, basically when the ocean water hits the land and it sends it off in a different direction. So here we have the California current that travels from north to south, and that runs into the equatorial current, and then the Tropic of Cancer current, and then I think I'm saying this right, the Kuroshio current, and then the North Pacific current. So this goes around in a gyre, in a circle. And I know this isn't an exact circle, but it goes around and around in a loop. And that basically happens when currents run into the land. So the upwelling of water brings up a lot of nutrients. Upwelling from the bottom brings up all the things that have died and decayed, and bacteria broke it down. So, all these nutrients are now ready to be used again. Upwelling of cold water. And again, this takes hundreds of years for like very cold, very salty polar waters to come up. But when they come up, they are full of nutrients that our oceans depend on. So I want to show you something that is called the conveyor belt, but basically, this is very dense water currents. So, this is very deep water, where this is more a shallow surface water. These are very deep water currents that take hundreds of years to travel a path before they upwell and become shallow. It's called the global conveyor belt to have things move across this way, and it's very deep water that eventually returns to the surface through upwelling. That's it for this section. I hope you have a great day learning science.